So yeah, again, thanks for the opportunity to present here today. My name is Bill Monahan. I'm the Quantitative Analysis Program Manager at FAST. That's the Forest Health Assessment and Applied Sciences team under the USDA Forest Service. I'm based out of Fort Collins, Colorado. My colleague, Ryan Hanovan, who's also going to be presenting here in this session, he's also with FAST up in Montana. Neither of us is going to spend a whole lot of time talking about our group, like who we are and work that we have going on, other work besides what we're presenting. So if there's interest in learning more about our group, we're going to post a few links in the chat so people can go to our pages and learn about us and particularly other work that we have going on that we're not going to have time to talk about today. What I am going to be speaking about is some of our work relating to mapping and monitoring forest health over large landscapes, these areas encompassing urban areas, and I'm principally focusing on wildlands and wildland-urban interface, or WUI communities. And I would like to acknowledge my co-author on this presentation, Colton Arnspiger. He's a contractor in our group with a company called Kikaha Solutions, and Colton helped prepare much of the materials that I'm going to be showing today. So to start off with an outline, a few things to go over. Start off with why monitor forest health, and then talk a little bit about why monitor at landscape scales. And then I'll go into the specific project that I'm presenting on called Tree Crown Health Monitoring and showcase a few examples of this work across the United States. So Choco National Forest in Oregon, Acadia National Park in Maine, Sumter National Forest in South Carolina, Yosemite National Park in California, and Gunnison National Forest in Colorado. And then I'll wrap up with some ideas around future opportunities with this work. So to begin with, why monitor forest health, and maybe more fundamentally, why monitor in general? And of course, there's different types of monitoring, but one of the main ones is to look at the current status and recent trends in resources. So in our case, we're especially interested in the current status and recent trends in forest damage or forest disturbance. And there's a number of patterns we want to quantify and assess with this type of monitoring. Broadly speaking, it's important to think about natural disturbances. So these are ones that are still largely operating within a historical range of variation, but then also novel or new and emerging threats, and a couple of big ones certainly being climate change and invasive species. And why we do this type of work is to inform management, and management over a multitude of scales, various spatial scales and temporal scales. A couple of examples, so longer term stand treatments that are designed to reduce or perhaps eliminate the likelihood and severity of future disturbances. And then things that are much more near term and immediate, so tactical identification and removal of hazard trees, say especially around high human use areas. The related question of why do this monitoring at landscape scales? I mean, monitoring is challenging to pull off under any circumstance. It's costly, it's time consuming, resource intensive. So of course, it's that much more trying to do it at landscape scales. And in the context of this urban webinar series, I think one important way to think about the importance of landscape scale monitoring is that these urban areas are embedded in a much bigger matrix of surrounding lands. So again, these wildlands and wildland-urban interface, or WUI communities. And the current and future threats to urban forests can come from these surrounding lands. So one way of characterizing landscape scale monitoring from an urban perspective is it kind of equates to basic situational awareness and preparedness for urban areas, urban forests, and understanding what some of the current and future threats might be. So there are a number of resources and programs and tools out there that relate in various ways to forest health monitoring. I am going to be talking about one in particular, our work on tree crown health, or TCH. And just to kind of start off by describing what that is, that what we're doing is we're looking at individual crown color or condition class with this work. And in a general sense, we're looking at green or healthy tree crowns, red crowns, which are typically dying trees or injured in some form, and then gray crowns, which are often standing dead trees or other types of tree injury. And we perform this work on high resolution RGB or red, green, blue imagery. So this is just basic imagery with human color vision is what we're working with. We tend to do most of this work with imagery from the USDA National Agriculture Imagery Program, or NAEP imagery. NAEP is collected for most states in the lower 48 every other year. So from a monitoring perspective, much of what I'm showing you here is work that we do on a biennial basis. In terms of tree crown health, these models, they're a form of supervised classification, and this kind of figure on the right kind of is an overview of how they work. The goal with the models is we're trying to take an image like this shot from an airplane in the upper left, where you can see some of the red dying trees in this area, some of the gray, which is like previous year's mortality and standing dead, and then the green healthy trees in this area. And we're trying to come up with a model that allows us to classify those tree color and condition classes into discrete units, like in the lower right over here, with the orange being the red, the gray being the gray, and the green being the green crowns. And once we can classify it like that, it allows us to then compute various summaries that we're interested in, such as the number of dead trees in an area, or standing dead trees per acre, or TPA. Areas of dying trees, or areas of standing dead trees, to areas of healthy green trees, things like that. The models, just briefly, they are operating initially in this red, green, blue color space. But for the models, mathematically, we translate that space into an equivalent color space called HSV, or hue, saturation, and value. And this work, we've published it, and some related work, another related model called TreeCap. And in the chat, I'm going to post a few of the links to those papers in case people want to dig into them and learn a bit more about how these models work, as well as where we're going with this work, some other work that we have going on to build out additional models so we can do some ensembling of the various models. The other thing I'll mention here in a couple spots is some ideas for discussion and Q&A. You know, I mentioned we tend to run these models on NAEP imagery. Here we're showing an example of an oblique photo out of an airplane. It might get you wondering what other types of imagery we can run these models on. And there's quite a few sources, and you may even have some yourself that you are interested in. And so if there's interest in that topic, we can certainly dig into it more in the Q&A session. So tree crown health supervised classification. These models are based on a very large training sample that we've collected across the lower 48. So we can run these models nationally, anywhere in the lower 48 at least. And when we do that and we compute measures of model accuracy, they tend to do pretty well. So these measures are on a scale from 0 to 1, with 1 being as perfect as it could be. So for our overall accuracy, we're about 0.9, and the kappa statistic is 0.85. And for these types of models and for those types of measures, those are pretty good. In terms of urban points, we don't have a whole lot in urban areas. TCH wasn't designed to target urban areas so much as it was, you know, bigger, broader landscapes of wildlands and WUIs. But it's about, well, a little less than 1% of our training points in urban areas, where urban is greater than 2,500 people per square mile. With that said, I think these models could do quite well in urban areas. Spectrally in RGB color space, a lot of dying trees, red crowns, gray crowns, green crowns, I think they tend to look pretty similar across these different landscapes and different environments. I think there are far bigger challenges to pulling off this type of work in urban areas, and Ryan's going to get into this a bit with his talk. And again, I think this is another really rich area for discussion if people are interested later. So yeah, this is the national picture. It gets interesting when we can take a tour of the US and zoom into our focal study areas that we've lined up here. We'll begin with Ochoco National Forest in Eastern Oregon. Ochoco is actually this unit with the red boundary over here. All these examples are the same, so I'll spend a little more time on this one just to kind of describe what we're looking at here. This kind of darker green area on the map is the landscape over which we ran our tree crown health model for this area. So in the next slides where we zoom in and kind of see the level of detail of mapping that we're doing, we have that level of detail throughout this entire area where you see the dark green on the map here. And we'll start here with this stand. It's a mixed fir stand in Ochoko National Forest. This is the year 2020 with the NAPE, and you can see how the model is doing quite a good job of picking out what's mostly a green, healthy stand, and some shadowing in there as well, which we have included in the models. 2 years later, in 2022, we've had a large fern graver mortality event roll through, and you can start to see the red or orangey crowns over here and how we're able to really capture those quite well in the model. This is a major event. It had quite a bit of coverage, and a colleague of mine coined the term Firmageddon, which is very appropriate given the scale of this mortality. Zooming out east to Acadia National Park in eastern Maine. So again, the green here is the area that we've kind of run our TCH model for. Acadia is actually this red boundary down here. And in this case, I've got an example here. It's quite close to the town of Bar Harbor. It's about 2 miles west. This is an interesting one. This is red pine scale mortality, quite intense in this area. You can see how it's quite active mortality here in 2018. We picked that up in the model as well. Red pine scale, it's an exotic invasive from Asia. So in Maine and a few other northeastern states. And then looking ahead a couple years further out, the mortality event has passed and we have a lot of standing dead still left on the landscape. So areas in the park, number of standing dead trees. Turning to the southeast, so Sumter National Forest in South Carolina. This is kind of central South Carolina, Columbia over here. The example I'm going to show is about 70 miles west of Columbia. So this is an interesting one here. 2019, we've got a number of pine stands, pine plantations in this area of the administrative unit of the forest, and doing quite well, green and healthy. A couple years later, and we have had a pretty notable mortality event roll through. This one, we don't really know what caused it. I asked around with a few of my colleagues, and it was a little inconclusive. And I think this is an important point as well with this work, is that we don't always know what causes the damage or the mortality, but work like this can be used in part to flag areas that we're interested in and conduct field checks to try and learn more about what's going on. Also pause here just briefly. So the southeast southern pine beetle is a big forest insect in the southeast, and we don't suspect this damage in particular is caused by southern pine beetle, but certainly a lot of damage there is. But another interesting thing about southern pine beetle is it does exist further north, including some urban areas such as Long Island, where it's causing mortality in some of those places. And of course, other insects or diseases you might think of, emerald ash borer is a big one that's caused extensive mortality of ash in urban areas of the Midwest, and sudden oak death out in California, targeting tan oak and coast live oak and California communities. Closer to where I'm at, there was an interesting one a few years ago, Douglas fir tussock moth, which is a defoliator that when it defoliates intensively can lead to mortality as well. We had a big eruption of that just outside of the city of Colorado Springs, and it was technically more WUI, but quite close and proximate to the city and very evident in the city, and certainly got a fair bit of coverage. So many of the examples I'm showing here, they're certainly more wildland and WUI centric, but a good number of these insects and pathogens and diseases are quite notable in urban and WUI areas as well. Turning back to the example, so Yosemite National Park in California. This is an area of the park. It's called Yosemite West. It's kind of a resort type area. We've got a number of structures down here as part of the Yosemite West area. This is a California red fir stand in 2020. And zooming ahead a couple years, we've had another fir engraver mortality event roll through, and quite a few standing dead trees in this area, quite close to the structures, potentially hazardous trees in this area. And the last example, Gunnison National Forest. So Gunnison is in southwestern Colorado. And in this example, well, it's quite close to the town of Gunnison, about 14 miles northwest. You can kind of see a home in this area. This is kind of the early stages of a Douglas fir beetle mortality event. You can kind of just see the orangey red crowns here that we pick up in the model over here. 2 years later, that's progressed a fair bit. We still have a lot of active mortality in orange, and some of the older mortality is now standing dead. And then kind of interesting coincidence, a couple of years later, this past year, a fire came through, the lowline fire. And we can still conduct these models in landscapes like this as well. It's challenging. These are complex landscapes, but a number of these kind of red crowns that are still in the area we pick up in the model over here. And then, standing dead post-fire, that's another potential use of this work where we're picking up some of it over here. I'll wrap up here, but before I do, one other point to throw out for the discussion and Q&A relates to a question people might have of early detection and how these models perhaps relate to that. And I think one question for me when I get that question is, what do we mean by early? How do we define early? How early is early? Right. So if we go back to this example, here in 2019, this stage of the event is early with respect to what we then had in 2021. So are we talking early kind of in this realm, or early being even earlier than what we had in 2019, what some people refer to say is like pre-visual stages of mortality, right as it's setting in? So depending on how we define early, I've got answers to that question, and that's another topic that I think we could spend some time with in the discussion and Q&A. So with that, I'll wrap up here with a few ideas for future opportunities with this work. We do this work nationally, as I showed on the previous slide, but we're running big landscapes in different parts of the US. What we're aiming to do is just get these models run wall to wall for multiple years across the lower 48. So we have the results everywhere and can work with them. We are interested in comparing and benchmarking our work against our National Forest Inventory, FIA, Forest Inventory and Analysis. So many of those measures that I mentioned, number of standing dead trees, standing dead TPA, those are things FIA measures as well. And the goal with this would be to see if we could, with TCH, have similar summaries that pair with FIA that we can release at higher resolutions and on a more frequent basis. We are interested in looking at different administrative unit summaries. So this map on the right, the pixels showing the individual crowns, that's useful for some applications, but over big landscapes, we're finding that there's a need to roll things up to a higher level. So like in national parks with the veg mapping inventory, being able to summarize standing dead TPA by veg polygon, things like that. And then urban applications. Like I mentioned, we didn't design this work to target urban areas per se, but I think there are some possibilities. And lastly, along those lines, people are interested in collaborating or requesting TCH support. We're happy to help. We have all the work, the data, methods, models published. We can get people set up to run these models yourself with your imagery. We can perhaps work with you on running some models and sharing results with you. If you're interested in any of this, probably the best way is to get a hold of me. I have my email listed there again, or let us know in the chat. Feel free to post anything there. We'll be combing through the materials later, and we can kind of reach out to people based on anything we come across. So with that, I'll pause, and I will pass it over to my colleague, Ryan Hanovan.